So now what we're on to is the start of Unit 5, and we are revisiting quadratics. Okay, so we looked at quadratic graphs previously in one of our units, and what we're doing today and over the next couple of weeks is solving quadratic equations and looking at more kind of parabola properties. Okay, so the first thing I want you to do is take this first heading, which is solving a quadratic equation graphically. We're not going to spend too much time on this. I'm just going to get you to copy down a wee bit, and it's fairly obvious. Okay, so we kind of already know some of this that's written up here. Linear equations, linear meaning x only is a power of 1, so like 3x plus 2 equals 5, that's a linear equation. That has one solution, right? It'd be x equals 1, that's one solution. Quadratic equations, whereas an x squared term, give two solutions. So, you know, x equals 4 or x equals 1, that they give two solutions there, okay, which we've already seen in our previous quadratic topic. Okay, so what's in this grey box is really important, right? The solutions of a quadratic equation are the same as the roots of the quadratic graph, right? Now, we've spoken about that before in our quadratic graphs topic. This, if you're asked for the solutions of a quadratic equation, it's talking about the roots of the quadratic graph. So I think it would be beneficial to write that sentence down underneath your heading, okay, because that is very important, okay? And if you need a reminder of what the roots are, write down the sentence underneath. Remember, the roots of the graph are the roots of a graph of an equation are the points where the graph cuts the x-axis. So if I just refer to this graph down the bottom right here, I've got my axis, I've got my quadratic parabola graph. The roots are the 2 points where the graph cuts the x-axis. So those 2 points there, they are the roots of that quadratic equation. So the equation is x squared minus 3x. And that diagram shows the graph of y equals x squared minus 3x. Okay, so if we were given the graph, we can get the solutions of the equation just simply by reading off what we see. Okay, we can see that the quadratic parabola cuts the x-axis at x equals 0 and at x equals 3. Right, because that's the 2 points that the graph cuts the x-axis. So that is all we would have to do to get the solutions of that graph, is just reading them off the graph. So the exercise we're going to do today, there's a short question on solving graphically. Literally all you have to do is write down x equals whatever the two numbers are that your graph cuts the x-axis. That's your solutions. Couldn't really be any easier. Okay, so that'll be no problem for you. What we're going on to mainly do today is look at solving quadratic equations by factorising. Okay, so that's your new heading, your main heading for today, is solving equations by factorising. Okay, so just put that heading just now. Okay, it says the more common way to solve quadratic equations is to use algebraic methods such as factorising. That is the first method we're going to use, okay, because most often we won't have the graph to look at. Okay, so we have already looked at this before in previous quadratic topics. You remember we factorised a trinomial or something else into like two brackets or a letter in a bracket. We brought each thing down, set it equal to 0, and then solved it. That's all we're doing here again. It's the exact same. Okay, so I don't think we should have too many problems with this today. So let's copy down example 1. Example 1a, if we were given the quadratic equation, now these are already in factorised form, so we've got x bracket x plus 1 equals 0, and we're asked to solve it. All we have to do is take our x down and say that x equals 0, that would be our first root, and then the other one would be x plus 1 equals 0, which when you solve for x gives you x equals minus 1. So the two solutions in this case are x equals 0 and x equals minus 1. So anytime you only just have an x as a kind of common factor, that will always just give you a root, a solution of x equals 0. Okay, example B, again in factorised form, is x minus 5 bracket x plus 3 equals 0. To solve this, we simply bring each bracket down separately. We say that x minus 5 would equal 0, therefore adding 5 to both sides, x equals 5. And we would say x plus 3 equals 0, taking away 3 from both sides, x equals minus 3. Okay, so what I want you to be thinking in your head is, if I was to draw, a graph of this, that means that this quadratic graph would cut at the x-axis here at the points minus 3 and at the points 5, and it would, look something like this. It would come down in minus 3 and then cut again at 5, right? It would look something like that. Okay, so that I want you to be picturing that kind of image in your head when we are finding these solutions. Okay, the last one, again, is already factorised for, so all I have to do is bring down these two separately. Say that 2x plus 5 equals 0. So just a little bit extra to do. 2x equals minus 5. Divide by 2, x equals minus 5 halves. 3 minus x equals 0. In this case, I'm going to add x to both sides to get my x positive. So I just get 3 equals x, or x equals 3. Right, so that is solving quadratic equations by, well, we've not actually done any factorising, but what we're going to have to do is turn, first factorise them into brackets and then just do exactly what we just did. All right, so as it says under here, if the equation is not already written in brackets, make first, rearrange it so that we have everything on one side equal to 0, factorise the left hand side and then solve the way we've just done. Okay, so we're going to look at some examples where we have to factorise and solve, and then I'm going to let you crack on. So example number 2, we have how many in this page? Right, we have 6 to do in this page before we start our own exercise. So really this is just factorising practice, that's all this is. So solve x squared plus 11x equals 0. Hello.
Is that on the next page, or is that 2 pages after that? Because I've got other stuff and it's like C, D, E and F for the next question.
No, that should be the next page.
Okay.
Just look for example 2, where it says example 2. Okay, example 2, x squared plus 11x equals 0. Write that down first of all, please. So you're factorising this. So your 3 things you're thinking of when you factorise is you're first looking for a common factor, then you're looking for a difference of 2 squares, then if it's still needing factorised, it's going to be a trinomial. Okay, but in this case we've got a common factor of x. I hope that's easy to see. So take x out the bracket. What would go inside the bracket? That's going to be x plus 11 equals 0. It's very, very important in your working, guys, that you put equals 0 on every line, because you can't solve it if you haven't written this equals 0, and you wouldn't get actually the marks for it. Okay, you have to make sure you write equals 0 all the way down to the end. So now to solve this, I bring my x instead of equal to 0, and then that's just one of my solutions. And then the other solution, x plus 11 equals 0. So taking away 11 from both sides, that's going to be x equals minus 11. Okay, and we'll just keep going through these examples. 3x minus 6x squared equals 0. Common factor there is going to be 3x. So take 3x out. Open a bracket. 3x times what is 3x? 1. 3x times what is minus 6x squared? That's going to be minus 2x equals 0. And now just bring each one down to solve. So if 3x is equal to 0, we would divide each side by 3. 0 divided by 3 is still 0. And the other one is 1 minus 2x equals 0. So add 2x to both sides is going to be 1 equals 2x. Divide by 2, that's going to be 1/2 equals x. Or, if you prefer, x equals 1/2. Okay, just let me know if I'm going too fast, or if you've got any questions you need to ask, just shout out, please. Obviously, I can't see any of you, so I don't know how fast you are copying it down. Next one, x squared minus 9 equals 0, 64 minus x squared. These are both difference of two squares factorising, okay? So we've got a squared thing, take away another squared thing. So difference of two squares is what I need you to be thinking of here. We did this one in the starter. So straight away we can go for x plus 3, x minus 3 equals 0. Bring each bracket down. X plus 3 equals 0, so therefore x equals minus 3. That's one solution. X minus 3 equals 0, so therefore x equals positive 3. Okay, I hope that's not too bad. Careful of this next one, 64 minus x squared. Now that is 8 squared minus x squared. What you have to do though is you have to keep the number in first in each bracket and then the letter second. So you have to keep the order that they're written here. Okay, so it's going to be a positive 8 and a positive 8 and one positive x and one negative x. Okay, you can't have it the other way around. Okay, that's not going to be correct if you have x plus 8, x minus 8. Yeah, it has to be 8 plus x, 8 minus x. Okay, so keep it in the order it's written in your expression. Okay, bring each bracket down. 8 plus x equals 0, so taking away 8, x equals minus 8. 8 minus x equals 0, we're going to add x to the other side to give me x equal to 8. So 8 and minus 8. So if you've got a difference of two squares, the solution is always going to be plus and minus of the same number, basically. So it's going to be symmetrical around the y-axis, and the two roots are going to just be plus and minus of the same number. So I think that's easy enough to do. E and F. Now, 2x squared minus 72. Well, this is, it kind of looks like a difference of two squares, but there's a common factor bit to do first. So there's a common factor of 2, which we must take out first. That gives me x squared minus 36 equals 0. And now that we've got that, we now do a difference of two squares inside that bracket. So that one bracket will become two brackets. X plus 6, x minus 6. Okay, I hope this is okay. This isn't really new stuff. This is just working on factorising. And then what you need to know about... So in the previous example, when we had an x outside the bracket, so in example A here, we had an x outside the bracket and that became x equals 0. But in this one, we've got 2 outside the bracket. Now, anytime you have just a number, like if I brought this down and said 2 equals 0, well, that doesn't make mathematical sense. How can 2 equal 0? So that's rubbish. So actually, whenever we have just a number outside the bracket, we don't use it as one of our roots. It just disappears, right? We just ignore it, basically. So anytime there's just a number outside the bracket, like a common factor that's a number, just ignore it and just bring down your two brackets the same as the last two examples. So x plus 6 equals 0, so x equals minus 6, and then it's just going to be the opposite. X minus 6 equals 0, so x equals 6. Okay, and you're thinking in your head, if you've got a quadratic graph in your head, a parabola, and you're knowing that these 2 points are going to be the two roots, the 2 points where they cut the x-axis. This one, there's no common factor, it's not a difference of two squares, so it must be a trinomial. Now, you need to basically factorise this in any way that you can. I would recommend trying to do it mentally when it's all positives, because if it's all positives, it must mean it's x plus and x plus, which equals 0, and then all you have to do is think of these two numbers. You need to think of two numbers that multiply to give me 5 and add to give me 6. It's not quite the same as the one we did in the starter, although it looks very similar. In this case, it's two numbers that multiply to give me 5 and add to give me 6, which is going to be 5 and 1. So it's x plus 5, x plus 1. Okay, so if you did the whole AC method, you should still get the same answer. But when it's all positive, I'd recommend, to save time, you know, for ones that are feeling happy with factorising, I would recommend you just try and do it, you know, in your head like that. Now bring each one down. X plus 5 equals 0, so x equals minus 5. Then x plus 1 equals 0, so my other solution is x equals minus 1. So that is really all we're doing today, is factorising the expression in any way that we can. Common factor, diffs of two squares, trinomial, and then finding the two solutions. That's all we're doing. Does anyone have any questions about that right now? Right, I'm just going to go to the Unit 5 booklet, which you should see in the files in our Teams page, but I'm going to get it uploaded just now.